Next speaker is Phillip Davis from Appalachian State University, who also happens to be the winner of the Best Student Technology Award for this UGM. So congratulations. And his talk is entitled "A Rust Library Crate for iRODS." Take it away.
All right. Thank you, Corey. Right. So I added a word here, which is experimental. So hi, everyone. My name is Phillip, like Corey said. You might remember me from the talk I gave at last UGM, where I said I would be working on this thing, and I'm here to give a progress update. Like Corey said, I graduated actually a couple weeks ago with a master's from App State. I interned with iRODS during the summer of 2022 and 23. In 23, I worked on sort of protocol plumbing stuff, and that's sort of what set me up to work on this project. And since graduation, I guess I've been freelancing. So first of all, I'm going to give a quick overview of Rust and some of the design implications that it had for the client and what it made possible. I'm going to give a quick tour of some code snippets, but again, this is an experimental client, and so most of the meat of the talk is going to be about housekeeping and how I see the project moving forward. So this project was completed as part of my master's degree, and so I would not say that in any way, like right off the bat, it's not ready for production, just to be clear. So first of all, why Rust when we already have clients in so many other languages? So the first thing is Rust makes guarantees about memory safety that are pretty strong. And in this context, that means data safety. It is actually pretty hard to get random garbage if you're writing Rust. It gives you reliable concurrency, which is obviously something you want in this context where you might be doing parallel transfer, or you might want to spin up a large connection pool or something like that. It gives you all of these things with the guarantee that it will perform at least competitively with something like C++. It has a type system that also gives you pretty strong guarantees. So this means like if you're parsing JSON and Rust tells you that it successfully parsed that JSON, it will like into some complicated structure. You have very, very high guarantees that it will that it represents some valid data. Rust also has an absurdly powerful macro system, which I think offers a lot of room for exploration. For example, you can execute arbitrary Rust code at compile time. And that allows you to do some things that just seem like witchcraft. And the final reason is just that I like it. Rust is a nice language, and I learned a lot about both, iRODS and programming in general working on this project. So what is like the high-level view of this client in particular? One is it's async everywhere that network operations are involved. For the moment, it only runs under Tokio, i.e. it only runs under one asynchronous runtime. This is because there are a couple places in the code base that use Tokio specific like task managing primitives. There is precedent in other Rust crates for establishing sort of a generic interface for async runtimes, but Tokio is by far the most widely used one, so that was not very high priority. From the beginning, one of my main goals with this project was to make it easy to drop in, replace how you encode the protocol. I.e., do you want to use XML or the native sort of bit level scheme? And this is because obviously there's been a lot of talk from the iRODS team recently about changing the way that the protocol is encoded, or perhaps changing the protocol itself. And so it's important for this client to be sort of future-proof to changes like that. It's also designed with longer running connections in mind. And for example, it has like buffers that grow over the lifetime of the connection. And so, the number of allocations you'll be doing as the connection lives longer will decrease potentially to zero, maybe not. So because we can execute arbitrary rules or execute arbitrary Rust at compile time, you can write your rules in Rust, meaning like you can define a struct that will know how to execute an iRODS rule language command. We'll see that, I think, on the next slide. Another note is that this is probably not cross-platform. I don't have a Windows box to test this on, but there's actually a bug in the Linux kernel that requires some tricky handling of, for example, the parallel transfer, how that deals with file system operations. And I really, really strongly doubt that would, work on a Windows machine. In any case, so on the left, you see an example of what I meant by writing your rules in Rust. So this thing here is called an attribute macro. And in the body parameter, you give it the, body of your rule. These, I guess you could call them like star strings, star substrings correspond to these parameters here. And we can actually check to make sure that these are like correspond to variable names. Then we have output, which currently is just no or exec rule out. And what this macro does is generates a very large amount of code that teaches this struct how to do this, which just packs up everything in a way that the iRODS server understands and sends it to the server. And this allows you to get strong types in your iRODS rules, meaning like it can be an exec rule out, or we could potentially expand this to a number of strings, however many string outputs you want. On the right, you see the manager struct for iRODS connections. So currently, connections are fairly tightly coupled with a connection pool, which is implemented using a third-party library called Deadpool. And this struct basically defines the pooling logic there. But as a side effect, you see what I mean by generic, right? So we have a protocol encoding, which is currently only XML is implemented. You have connection or connect, which is a generic trait that lets iRODS work under either TCP or SSL at this point. But because that affects the actual messages that go over the wire during the handshake, it needed to be pulled out into something separate from just using a TCP or SSL socket. And then finally, we have this A parameter, which is generic over authentication schemes. So once again, the default, which is native authentication, is implemented right now. But if you wanted to implement, PAM or Kerberos or whatever authentication you wanted, you could just drop in one of these. And so from there, it's easy to just take a connection and run it through these things. And then at the end, you get a connection that is ready to send things over the wire. Another thing that's different about this client, as far as I'm aware from other clients, so these functions are defined on the connection struct. And this M parameter is a generic representing a message type, i.e. a deserializable. This means that when you pull a message from the server, when you read a message from the server, you have to say at compile time what kind of message you expect it to be. This has not posed a problem since I have not run into a case in my writing where where you don't know what sort of message you should get back from the server. Obviously this message has side effects because it reads from the server. So you can't really like try again. But it would obviously be like trivial to implement a version that didn't have side effects. It's just that I haven't encountered a situation where I needed that. So let's now talk about sort of the large number of caveats and things that have to be done. So it's kind of hard to see because I struggled getting a screenshot here, but right now, one of the main sort of problems in the Rust ecosystem right now is that there isn't really a consensus strategy for handling errors. And one side effect of this is like it's not obvious how to do it in your projects. Right now, all errors are just basically a grab bag other type with a string attached to them. This is fine in like a binary application, but in a library, maybe you want to respond to certain errors in certain ways. For example, at a bare minimum, iRODS, the C++ source code has a gigantic file with, I want to say, hundreds of different error codes defined, and there should be enum variants for all of those. Another thing is that I have worked on this, like I've desk checked all the features as I've implemented them, but comprehensive integration tests would be like key before I feel confident saying that this is like a quote unquote real client. Another thing is that in order to in order to be compatible with older versions of iRODS that have sort of idiosyncratic escape strategies for XML and unescape strategies, I implemented a little bit more customization in the XML library that I'm using. And the PR for that is currently in flux. There seems to be some question about how it would affect performance. So I've been testing against the local copy that I have of that library. Obviously, you could just sort of pre and post process the strings if you wanted to, but that would require parsing the XML twice, and I'm trying to avoid that. So it's sort of ambiguous where that stands. There are also more features that need to be implemented for this to be fully featured. So for example, the way that the iRODS server recognizes like iadmin change password requires kind of tricky bit fiddling pseudo obfuscation algorithm that I'm still trying to debug, as well as things like ticketing and other things. But I suspect that those features would be slightly easier to implement. So some other things that would be nice to have. I've been thinking about statically checked rule syntax. Static is in quotation marks because so we're not gonna, I have no plans to implement like a first class like iRODS rule parser. However, one example of a way that this could be done is for example, Leptos is a sort of combo front-end, back-end framework for Rust. And the way that it allows you to write HTML in Rust is it takes the macros that you write, compiles, like turns them into HTML text, and then sends them to a headless browser or something at compile time, something that knows how to read HTML, and then sends you back whatever error message it might have gotten back from that thing. And then it can just put that syntax error in your LSP or whatever else. So this way we could theoretically just send the rule to a Dockerized iRODS server and have it respond with an error code that says, if the error code is anything other than this rule is syntactically invalid, then the LSP is happy. Another thing that I think would be worth investigating is statically sized connection buffers. So right now, like I said, your buffers will expand over time. But you could, and this idea actually came from this code snippet on the right, which is from a Rust library designed to make the game Battlesnake more efficient, if you've heard of that. It allows, so you can actually pass specific numbers as generic types at compile time. And this allows you to get what this here is an array of cells that are of size board size. So this is known at compile time. So you still get customization. Like for example, if you just have a connection that's going to send small admin requests, you don't need a big dynamically sized buffer probably. In any case, if you would like this thing to exist and you would like it to be more robust than it is right now, here's a link. I just published this recently. Issue number 7 is a subject to change list of issues that are important to resolve before issuing a release or whatever you might want to call it. Yeah, right now it's just me. Haven't really touched it a ton since submitting it for the master's degree. But I think it is a promising start. Yep. Thank you.
All right, good job. Any questions? We got one over here.
Hey, Philip.
Hey.
I was curious, kind of in terms of prioritizing which features to implement first in the library, what made you reach for typing rules?
Typing pools. Well, to be honest, I was just thinking about, I was going through the list of features and I thought, well, it should be able to execute rules. And then trying to implement that in Rust in a way that wasn't kind of restrictive, because of how sort of strict and static the Rust type system is, was not going very well. And so at a certain point, I just sort of threw my hands up and said, all right, like if we're gonna do this, we got to do it right. And the crazy macro solution that I came up with was just what stuck.
Cool, thanks.
Okay. Yeah, this is an online question. Well, Terrell just answered it, but I'll go ahead and ask real fast. And I'll paraphrase. Is this a client or a new rule language?
It is a client, so it is the same kind of thing as PRC.
I got a question. So where did you find what did you find to be the most challenging part of this? Was it battling Rust in the borrow checker, or was it trying to port the iRODS protocol into Rust?
Most parts of the iRODS protocol are not very, they don't aggravate the borrow checker that much. There's sort of a pretty clear chain of ownership that makes it fairly easy to appease the borrow checker. Definitely the hardest part was trying to, I'd say it's trying to come up with like a type scheme that made sense. So like, for example, here, this, behind the scenes, this is sort of a linear types pattern, because, so like this returns a unconnected connection or maybe like unauthenticated connection. And then, this thing returns a regular connection. It's kind of a mess at a certain point to look that clean, because you can't have the iRODS connection changes state over time so much that it was sort of hard to, especially during the handshake, that it was sort of hard to model that in a way that was clean and incurred minimal runtime cost. Yeah.
Okay. And was this your first application in Rust? Or had you written other clients just to learn the language before you took on your attempt at writing the iRODS protocol in it?
Yeah, so part of the reason that I've made toy projects in Rust, but part of the reason that this took that it didn't get farther off the ground was that I was kind of learning serious Rust as I was writing it. Especially asynchronous Rust, which is in some ways just a totally different language. But yeah, it is my first real project in Rust, I would say.
All right. Well, thank you.
Great, thank you all.